welcome to the last day of Unity at GDC 2019. How's everyone doing? Is there still some energy or are we dead? Okay, energy, yay! All right, cool. So there will be even more energy, I bet, because I'm going to show you something really cool, Unity's visual effect graph. But yeah, to start, my name is actually Alicea. I'm an evangelist at Unity Technologies. I cover media and entertainment. And I'm really excited to get to show you one of these brand new tools in the editor. Now, before I do, one thing I want to show you is that my presentation style looks a little bit different because my slides are actually running in Unity. And so all the visual effects that you're going to see in this part of my presentation, these are actually real visual effects that are running real time in the editor as I'm presenting. So if I actually go down here into my scene view, and let me scooch in over here. You can see that I have my text and effects and everything. So everything you're seeing is real, legit, real time. So let's go ahead and get started. All right, how many people here have who here has seen or used the visual effects graph before? Okay, only a few of you. Great. So for those of you who are new to this, this will be a great overview of what the tool is and what it can do. And for those of you who do know about it, you'll hear about our roadmap and the upcoming features that are coming to this tool. So what is the visual effect graph? This is a new next generation tool in Unity to create stunning visual effects in real time in the Unity editor. Now what's special about this is that you can create these effects without having to program. You can use a hybrid stack node-based system to drag and drop parameters and connect nodes and more to generate these visual effects. But if you do program, the good news is that this is programmable. You can extend this. You can create your own custom parameters and more. And when you make a visual effect graph, it creates a self-contained asset in your project folder. So when you make a graph, it's there in your folder. You can drag and drop it into different scenes that you want to use it in. And what's cool about it is that you can actually expose its values. So you can, for example, tinker with it in the inspector instead of having to open up the graph every time to make edits, or making edits to the graph in your code. And lastly, this is tailored to support platforms that support GPU compute. So this is going to be running on your higher end devices, your most recent consoles, and Mac and PC. Setting up the visual effect graph is incredibly easy. Who here has used the package manager tool in Unity? Okay, most of you know what it is. So essentially, it's where you can get tools for your Unity projects straight from the Unity editor. Go to Window Package Manager, and you could install visual effect graph in Unity's version 2018.3 and above. Now, note that in order to use the visual effect graph, you'll have to use the high definition render pipeline. And another thing to know, a pro tip, is that when you download it, in your preferences, you're going to have a setting for experimental operators for the visual effect graph. Be sure to check that off because you're going to get access to a bunch of cool nodes like GPU events. So the key points here to remember: this is a super artist-friendly tool. You don't have to program to use it. There's lots of ways that you can customize it, and what's special about this is that it's running on the GPU. So I'm going to give a breakdown of why this is special, but the most common question that we get about this is, cool, this looks like the particle system, how is it different? But I'll get to that in the next slide. The scalability of the effects here are what I think is really impressive about the visual effect graph. You can make anything from small, tiny sparks to plumes of smoke, to giant explosions and planets and more. You can do so much. Kind of really the limit is your creativity. Another big point here is that it follows industry trends. So if you're an artist, you're going to find a lot of similarities to digital content creation tools out there. When I use the visual effect graph, it reminds me of a lot of like the things I'll see in Photoshop or in Houdini. And lastly, we're able to create such gorgeous graphics because we're taking use of the HD render pipeline. So comparison versus the particle system. This is different. Who here has used the particle system in Unity? Okay, so a lot of you are familiar with it. The big difference here is that the visual effect graph does all the heavy lifting on the GPU versus the particle system, which runs on the CPU. So what does this mean? On the CPU, you can generate thousands of particles, whereas with the visual effect graph, you can generate millions. The CPU-based particle system is good for doing simple effects, things like smoke. But with the visual effect graph, you can start getting really complex simulations going for things like fluids. Now, there are still benefits to using the particle system. So the underlying physics system is a key part of the particle system because they both run on the CPU. So Unity's physics and the particle system can easily talk to each other because they're both running off the CPU. You can do physics with the visual effect graph, but right now it's currently more focused on working with primitives, signed distance fields, and depth buffers. Another benefit to using the CPU-based particles is that there's gameplay readback. So if you want your particles to kind of have a strong role in your gameplay, make use of the physics and affect kind of different items in your games, that's still a good thing to use. You can do some small stuff like that with the visual effect graph, but there's going to be some latency. But another big plus to the visual effect graph is that you can ready frame buffers with it. So what makes up a visual effect graph? How does this all work? You start out with context. So your context here are what basically are like the base building blocks for your visual effect graph. Now here, this is kind of like a standard base system that we have that has spawn, context, initialize, update, and quad output. So spawn, kind of similar to spawn in the particle system, is just determining how your particles are being spawned in your scene. For those of you who program, initialize is similar to your start method. All the things that you want to apply, all the information that you want to apply to your particles when they start up, things like velocity or lifetime. The update is for all the context that you want to have affect your visual effect graph as it's playing, things that are changing the particles over time as it's running. And the quad output, or any kind of output that you use, is what determines how your particles actually look and how they are rendered in your scene. Now, contexts are nothing without blocks. Blocks are the magic that make the context happen. So by using blocks, you can essentially give those contexts the information that they need to start processing your visual effect. Now, there's tons of different kinds of blocks. You can go in and check it out and see that you can have things like setting the size, or if you want to use a 2D sprites, like a sprite sheet, you can use a flip book and more. There's so much you can do and so many combinations that get a lot more powerful when you connect them with nodes. So nodes are parameters and different ways that you can affect the blocks in your context to really customize and to really get in there with the details and kind of really building up your effects nicely. So supported file types. This is not a warning, I just thought it looked really cool. So the visual effect graph supports assets that allow you to represent volumes, forces, collisions, and more. So these include point caches, vector fields, and signed distance fields. So for those of you who do work in things like Houdini, those are very familiar file types to you. You can create those in software like that and bring them over into Unity to use in your visual effect graph. So instead of just telling you about how cool this all is, I'm going to jump into an actual demo. This is one of my favorite visual effect graph, like all the pretty little butterflies. So, but let's go ahead and see how this works. No, it crashed. Okay. So this is currently in preview, but we're going to go ahead, and since that I'm not using it anymore, it doesn't matter. So here I have a brand new Unity scene in my project. And what I'm going to do is I'm going to create a brand new visual effect graph to work with. So I'm going to go to my project folder and right click, go to create, visual effects, visual effect graph. So there, I'm set. I created a base visual effect graph to work with. I'm going to go ahead and drag it into my scene here. And you can see that I have the default visual effect graph playing. So if I double click my graph here and open it, here I have the context that I'm going to use for my project. So I'm going to use you can pan around here and zoom out, and let's see. So starting in the spawn context, right, we're determining the constant spawn rate. So what I'm going to do is I'm going to take this base particle system, and I'm going to just make a couple of changes to it so you can see in how just a few steps you can start building some really cool looking effects. So I'm going to go ahead and up the constant spawn rate to 25,000. Now in the initialize, I'm going to up the capacity to a very specific random number, but this is the number that we decided looks good. All right. There we go. 65,536. So now you see, as I'm making these changes to my visual effect graph, they're automatically updating here in my scene. So if I bring this closer here, there you go. So now you see we did that change and it happened instantly. This is really great. So as I'm making changes, I can understand how these are affecting my graph, and I can go back and make edits and so on without having to go like back and forth and opening lots of different things. But yeah, so I'm going to go ahead and set the bounds of this here over to 0, 0, 0 and 5. All right. So I'm happy with the size of the capacity now. I'm going to remove set velocity random because I won't need it for what I'm going to show you. I'm going to keep set lifetime random. So essentially this sets the lifetime of my particles to random seconds. So the minimum a particle can last is 1, and the maximum it can last is 3 seconds. So, so yeah. So now what I'm going to do is I'm going to add a position sphere. And essentially, this creates a kind of sphere emitter for my particles. Now I'm kind of pushing them in a circular shape. And I'm going to keep this to surface and randomize. All right, I like where this is going so far. Now going over to update. Here I'm going to add the contexts that are continuously going to affect my particles. So what I'm going to do is I want to use actually one of those special file types that I mentioned earlier. In this case, a vector field. I can make this, for example, like in Houdini. So really easy to add blocks, by the way. You can just click on the context, press space, and just start typing for whatever you want. Those of you who have used shader graph might be finding this very familiar. So, all right, vector field. Would help if I spell it right. There we go. So now here I have a vector field that's being used on my particles, and I'm going to, let's see. I'll edit these settings to be, I'll edit the size to be 2 across the board. And when I drag up the intensity, you'll see now they really start kind of swirling around and doing some cool stuff. Now in my quad output, this is where I'm going to determine how my particles are going to look instead of using that base kind of little clock look. The first thing I'm going to do is set the blend mode to additive. Now it's all glowy and pretty. And I'm going to keep the UV mode at simple. And what I want to do here is change the default particle I'm using to the sparkle particle I have. And so I have my particle there. Now I'm going to make some changes to kind of really crisp up how that sparkle particle looks. So I'm going to change the orientation to go along the velocity instead of just facing the camera plane. And essentially that means that it's making the particles kind of face the direction that they're flowing in. So for set size, over life, you know what, I'm going to, I'll leave that there. So I'll add a block for set size. Now set the size to 1. Actually, no, I'll leave it how it is. All right. So yeah, so then what I want to do now is kind of set the X scale of these particles. So I'm going to set it along the X value. I'm going to set the scale to 1. And then what I'm going to do is scale the Y value over time, or over life, I should say. Sorry. Set scale over life. Add it to my Y value. And essentially what this is doing is that it's determining the size of my particles as they're kind of being spawned in my scene. So in this case, if I kind of I'll add a key here in my my graph here. And essentially what this is saying is that they're going to start out really small here when they're first generated. The scale is going to raise up. And I'll raise these up a little bit more to make that more visible. And then at the end of their lifetime, they're going to also start to scale down in size as well. So, I'm going to make a quick change because I see what I did before that I wanted to do. All right. Now, basically, so the way, and really like a lot of this is like you can tinker with these effects to achieve the different looks that you want to create. So in this case, I'm going to add a cool HDR color gradient to this. And straight up, this didn't come out how I was planning it to, so I'm going to do a quick review again to see what I want to change. So I have my blend mode, orient along velocity. Oh. Oops. All right, there we go. Okay. So here we go. So now, so basically what I totally didn't catch that I typed a much bigger number for the scale of my X than I was intending to, so my particles were looking way too big and kind of like blurring with each other. But now I have a kind of a nice soft kind of like little fireball effect happening. So in just a few passes, we created an effect like this. And so like if I have more time than just this 20-minute session, I will be like jumping into a deeper, bigger graph and showing you how to create these cool effects. For now, I'll show you this video. Now, if you had a little bit more time than I did just now, you can start creating some really cool effects like this. Some of these you saw in the presentation that I did just now, so you saw the real-time versions of those. But you can create so many different kinds of stunning effects with the visual effect graph. Now, these are some of the visual effect graph samples, and they're available for you online to play with through the GitHub. But also, if you haven't checked it out yet, come check out the visual effect graph kiosk here at the Unity booth, over at the artist tools section down there. You'll be able to play with these samples and see how they work and actually kind of tinker with them for yourselves. So now for sharing some roadmap news and resources. In 2019.1, what we're going to do is that we're going to add initial lightweight render pipeline support. Now note that this is going to be for unlit particles only. And also, even though it's with the lightweight render pipeline, it's still only going to apply for devices that support GPU compute. And then we're going to be adding camera buffers access. So you'll be able to do particle collisions based on your depth buffers. We'll have static mesh sampling, so you can spawn particles on your static meshes. And we'll have a point cache volume baker. So this is really cool because instead of having to jump in to software like Houdini to create your point cache, we're providing a kind of little UI option for you to create it right within the Unity editor. And then we also have pre-warming. So pre-warming is awesome because in a great example that I heard it for is, let's say you want to have smoke coming out of a vent, but the effect that you're looking for really happens about like 10 seconds into your particle system running. By using pre-warming, you can have the visual effect graph automatically start at that kind of 10-second point where it kind of looks good and when it appears in your scene. And then we're consolidating core functionality, and essentially this means that we're making some changes and doing some debugging to get ready for some additional upcoming features. So in 2019.2, we're going to bring the lightweight render pipeline lit particle support, but again, compute only. We'll be adding motion vectors, so this will help you have a cool and correct looking motion blur on your on your visual effect graph. We'll be adding support for ribbons and trail effects. And subgraphs are going to be coming in 2019.2 as well. This is really cool because you can take a selection of the visual effect graph that you're working with and save that as a subgraph asset that you could use in other graphs, or you can even nest subgraphs together in one graph. And we're also bringing a skinned mesh sampling. So this is good for example, if you want to spawn particles on things like animated characters. So in 2019.3, we're hoping to bring this out of preview. And we're also going to be bringing a shader graph integration, so you can use that to edit your fragment shaders for your particles. But that's the gist of it. The visual effect graph is really, really cool. Here are a bunch of resources that you can reference for when you're creating your own visual effects. So here we have the general info page for visual effect graph is that link at the top. You can download the samples off the GitHub and start playing with them in this link right there, the visual effect graph samples. Or you can play with them here at the Unity booth. We have them over at the Artist Tools kiosk. Then we have the VFX Toolbox, which is, check it out, it has a bunch of cool additional tools that you can use with the visual effect graph. You can get that from GitHub as well. And then lastly, we have an excellent deep dive blog post that goes really in depth to what I showed today for those of you who want to learn more. And if you're working in visual effect graph, please share what you're working on with the community. Hashtag visual effect graph has some amazing stuff there. It's also a really cool way to get connected with other people using the tool and get some inspiration to see how they're working with it. But yeah, that's it. Thank you all so much for joining. Does anyone have any questions?
Hi, thank you so much.
Hi, yeah.
Yeah, so I'm wondering, what do you recommend the HDRP plus the visual effects graph for stuff like Vive and Rift VR experiences?
So right now, it won't be supporting VR, but it's something that we're looking into. I can't say more just yet.
Okay, great. Thank you.
Yep. Any other questions? All right. Thank you so much, everybody.